Welcome to today's deep dive. If you were to look under the desk of, say, a school administrator or a security guard, you might spot what looks like a retro arcade button.
Yeah, just a simple, discrete piece of plastic, right?
Exactly. But this specific button from HGTV Supply's catalog, the Advanced Network Devices Smart IP button, costs a staggering
Which
$309.48.
is wild for a button.
Right. So today, our mission is to figure out exactly what makes this single button smart enough to justify that price tag and why it requires heavy-duty networking tech just to function.
Right, because to the naked eye, you're just pressing a piece of plastic.
Yeah.
But beneath the surface, you are actually triggering a highly sophisticated digital tripwire.
Okay, let's unpack this, starting with the physical design, because I think it tells us a lot about the intense environments this is built for.
It really does. I mean, it comes with a mounting bracket for under a desk and an LD light to show it's connected.
Right, but here is the crucial detail. The plastic casing is entirely flame and ignition resistant.
Yeah, that's huge.
And it relies exclusively on a hardwired Cat5 or Cat6 Ethernet cable. No batteries whatsoever.
Zero batteries.
No, wait, a $300 price tag for a panic button?
I know, it sounds crazy.
Like, why on earth do you need a thick, hardwired Ethernet cable and flame-resistant plastic just for a button press? I mean, why not pop a standard battery in there and use a wireless signal? It just feels like massive overkill.
It absolutely sounds like overkill until you consider the stakes. This isn't just ringing a doorbell down the hall.
Right.
In a life safety scenario, like a campus lockdown or a severe fire, wireless signals drop, routers get overloaded, or the power just goes out completely.
Oh, and batteries die silently.
Exactly, batteries die. So by hardwiring it with an Ethernet cable, you guarantee uninterrupted power and a dedicated data line.
Wow, okay.
And that flame-resistant casing is a vital fail-safe, too. If a fire breaks out, that button has to survive the extreme heat long enough to consistently transmit its alert.
Man.
You really cannot afford a drop signal when lives are on the line.
Ah, okay. So the physical hardware is actually designed to eliminate any single point of failure, which actually explains the Ethernet cable.
Right.
It's not just drawing power, it's plugging directly into the building's central nervous system.
Exactly. That cable is the pipeline for a very complex software ecosystem. According to the specs, this button integrates with VoIP systems, Voice over Internet Protocol, and it's SIP call enabled.
Let's pause there, because throwing around terms like SIP enabled can sound like a foreign language.
Yeah, it really can.
What exactly is that doing when someone actually presses the button?
So SIP stands for Session Initiation Protocol. It's essentially the underlying technology that routes digital voice and video calls over the internet.
Okay.
Because this button is SIP enabled, the second it's pressed, it can instantly open a direct two-way communication channel over the IP network.
Oh, wow.
Yeah, and it's completely programmable through management software like Clockwise Campus. So you can set it up for push and release or push and hold commands.
Okay, here's where it gets really interesting to me. The specs say this single physical button has its own built-in web server.
Right.
How does a web server even fit inside a plastic button? And why does it need one?
Well, what's fascinating here is that we aren't talking about a massive rack of flashing servers. It's a tiny microchip embedded right inside the button's casing.
Just a little chip.
Exactly. That chip holds the device's unique IP address and its routing instructions. Normally, a basic button just completes a dumb electrical circuit,
Yeah, and a separate desktop computer has to interpret that signal and decide what to do.
Right, but because this button has its own micro web server, it acts as an autonomous miniature network dispatcher.
Wait, really? It does it all on its own?
It does. When you press it, it doesn't need to ask a computer for permission. It autonomously pings the main network to trigger campus-wide alerts, lock down electronic doors, or blast a warning over the intercom.
So it takes a very basic primitive physical action and instantly translates it into a highly orchestrated digital event.
That's exactly it.
So what does this all mean for you, the listener? Well, the next time you see a discrete little button mounted under a desk, don't underestimate it.
Definitely not.
It's not just a piece of plastic, it's a dedicated network node standing guard.
It really makes you reconsider the invisible digital infrastructure holding our physical spaces together. I mean, we're surrounding ourselves with these incredibly capable microcomputers disguised as everyday objects.
We really are. Which leaves you with a final thought to ponder. As everyday analog actions like simply pressing a button become hardwired to dedicated IP addresses and embedded web servers, how long until every single physical object we touch is just an extension of the digital network?